Thank you very much. So if I come first, maybe I have more time.
Yeah.
I'll try to stick to the time that I'm allowed. So, I will talk about the status of development of wind energy and in the global perspective. So I will speak about this. I will give a small historical milestone of wind energy. It's not going to be a full history course. Then I'll talk briefly about the energy sector as we see it in the world today. Then I will talk about the status of development of wind energy in general. And I will conclude with more attention on offshore wind energy, which I think is the topic of interest here in this group today. I'm from the eastern part of Canada, where you see the circle, 3 provinces that are called the Maritime Provinces. So brief story about wind energy. Essentially, I started in the 1980s, which I would call the emergence of CFD, computational fluid dynamics. Computers were starting to be performant and accessible. And therefore, scientists and engineers were seeing that we could try to develop some numerical model to solve the fluid dynamics equations. So to do that, to develop models, we needed some good, solid, rigorous experimental work on fundamental geometries so that we could validate the numerical models that we were developing, the first CFD models. And I was part of that as a student at MIT in the United States. And I had this picture in front of me in my desk, and the goal was to develop models, numerical models that could solve the fluid dynamics equation to reproduce this flow. And we did achieve that, developing some of the first models of CFD. Well, when you look at where was these experimental results coming from, well, they were from here, from the Research Institute for Applied Mechanics, RIAM, at Kyushu University. I jumped to the year 2000, which I would call the emergence of wind energy, large-scale wind energy. This is one of the first wind map of the world produced by DTU, the Technical University of Denmark. And on this map, if you look carefully, you will see that you will see the Earth, North America, you see South America, you see Africa, you see Japan, and the rest of the world. Where it is black and dark on this figure means that the winds are the highest. Where are the highest wind on Earth where there is land? Well, it's basically here, around here in Northern Europe, where you see UK, Germany, Denmark, and the North Sea. And most of the wind energy currently is being developed in that region of the world. If you look elsewhere on the planet where there is land, see that eastern part of Canada is quite interesting. But then after that, the best winds are right here in Japan, towards the north of Japan, but also including various regions of Japan. So Japan, from these first wind maps, indicates that Japan has a good wind resource for power generation. So this led to some of the work that we've done in my group in the year 2000s, which we'd call the mesoscale maps. This is my province, New Brunswick. It's about 300 kilometers by 500 kilometers. And on those maps, the orange and red colors are in regions where you can install wind turbines, not only generate electricity from renewable sources, but also make money out of doing it. So it's viable places to install wind turbines. Continuing in our region, we did what is called Prince Edward Island, which is next to my province. And you see that on this island, you can install wind turbines almost anywhere without doing wind resource assessment. And the turbine will generate a lot of electricity. Now, for those of you who remember your little school education, you will remember that Prince Edward Island is the land of Anne of Green Gable. And Anne lived in this region of the province which is highly windy. We also did the province of Nova Scotia. And again, the highlands here quite interesting. A dominant wind coming from the southwest, And then we did the offshore wind map of this province up to 10 kilometers. And right away, you see that when you go offshore, the wind resource is much better, much more interesting to install wind power plant, but much more difficult because you're offshore. So again, in the emergence of wind energy in the year 2000s, we started to see some really interesting work out of Japan. And I present some of them here. And there was many others, and we all know now that this was also coming from the Research Institute for Applied Mechanics, RIAM, here at Kyushu University. And we all know now this work from Oya Sensei. Continuing in this line of the emergence of wind energy, in a similar meeting in Vancouver in the year 2007 or 2006, we had the pleasure to meet Oya Sensei. He was part of the Japanese delegation in this meeting, and as you see, we have learned a lot from Oya Sensei in the early phase of wind energy to help us develop wind energy in Canada. As you know, Oya Sensei continues to do a lot of innovation work. This is the floating platform, maybe one of the first floating wind turbine in the world. So quite innovative and forward-thinking in his work. And I had the privilege to be here a few years ago in the year about 2014, 2015, my first visit here, and to visit this platform. And now we see that even pushing the innovation further with this type of multi-rotor turbine model here at RIAM Kyushu University. Now we're still in the phase of innovation in wind energy, but I would say that we're in the phase of optimization also. And to do optimization, we need to do a lot more finer modeling and more complex modeling. And so we start to see this type of work where a flow simulation is done on complex flow, real in situ type of simulation. And again, we see that this work is coming from RIAM, from the work of Uchida Sensei. Continuing in this optimization phase, again, the work of Uchida Sensei, very complex flow of wind turbines to understand the wake dynamics and wake interactions between different turbines. Many other great work here at RIAM at Kyushu University from other researchers, which are part of the institute. So basically, the Research Institute for Applied Mechanics, RIAM, here at Kyushu University, is an important player, is an important institution in the development of wind energy, not only in Japan, but also on the world scale. I would say that RIAM is like the Otani of baseball. Otani was good in Japan, and he's also good at the international level. Kyushu University is the same, good in Japan, but also good at the international level. So it's a privilege for me to be a visiting professor here at RIAM. It's an honor to address you this symposium here today. If I go to a brief overview of the energy sector, this is one of the first wind power plants in North America on Prince Edward Island, not far off the land of Anne. And this is wintertime in Canada. You're welcome to visit. Quite a nice country, but bring your hat if it's wintertime. This map summarizes the energy sector on the world scale. Where there's light means that there is energy. And essentially, the rich countries, the developed countries, have the money to buy fossil fuel, generate electricity, and have some light. So what this map tells us is that we are using way too much fossil fuel in the energy sector. At the same time, this map also shows us another problem, is access to energy. We see that access to energy is not uniform around the world. Fossil fuel is part of the problem. Renewable energy is part of the solution. So currently, about 70% of the energy in the world comes from fossil fuel, still comes from non-renewable sources, mainly fossil fuel and nuclear energy. And roughly 30% of the electricity comes from renewable energy, 60% from hydro, about 20% from wind and solar energy. But what's interesting is that when we look at the evolution of the additional power capacity installed every year, so for the last about 15 years, more and more renewable energy is being implemented to generate electricity. Now about 75% of new power capacity installed comes from renewable energy. Consequently, the investments are also for renewable energy. In 2022, it was the energy sector, the new power capacity sector, was $640 billion. That's billion with a B. So a huge industry, about 75% of that coming from renewable energy sources. Which renewable energy is being installed? Well, it's mostly solar because of technical maturity, but also cost effectiveness. And we see that also wind power in blue, year after year, a lot of installation being made, and hydropower decreasing in terms of installation capacity because of the lack of possibilities to install new large hydro dams. Why is this happening? Well, essentially, when you look at the life cycle of the GHG emissions of the various different power sources, we see that wind energy, offshore and onshore, is the lowest emitter of greenhouse gas emission in the energy sector. So this is the driver of seeing much of the wind energy being installed. Here in Japan, it's roughly the same profile as the world profile, roughly 75% of your electricity coming from non-renewable sources, about 25% coming from renewable sources, mainly solar, and also some biomass renewable energy. Wind still playing a small role in the electricity profile of Japan. But what's interesting is that the share of renewable energy in the total electricity generation in Japan is increasing year after year, mostly for solar, which is the kind of orange. More and more solar is installed every year, and biomass is increasing a little bit, but wind energy is still not a dominant source of energy here in Japan. We'll come back to that a little bit later. Now, if we concentrate on wind energy, essentially, we all know that wind power plant can be installed onshore on flat land. It can also be installed in mountainous area if you have access to those mountains, but also it's being installed in offshore areas. So where there's conflict of usage of the land, where the land is not available, such as in Japan, well, wind power plants are pushed offshore, and these are models coming from Europe. So historically, in terms of the wind power, the new installation, we see that in the last 20 years, roughly, we don't see the scale in the bottom here, but it starts in about 2001. We see that wind energy new installation, every year what is being installed, there is always more and more wind energy being installed. What we're seeing also is that the green bars are for onshore wind energy, and the blue bar is for offshore wind energy. So for the last 10 years, roughly, we see that offshore wind energy is being installed. This value is for 2021. So about roughly 100 gigawatt of power was installed in as new wind, and 21 gigawatt of that was for offshore wind power plants. In the last few years, we see that the growth more in more detailed format, and roughly 75% of the wind energy capacity installed is onshore, but more and more we see some offshore wind power plants being installed. Where are these wind power plants being installed? Well, onshore, there's in 2022, there was almost 70 gigawatt of wind power plant onshore installed. About 50% of that was in China. About 30% was in the USA, and then a whole series of other countries, with Japan being included in the rest of the world here at 14% capacity. In terms of offshore wind energy, in 2022, so recently, nearly 9 gigawatt of offshore wind energy was installed, so 9,000 megawatt of offshore wind energy. About 60% of that was in China, about 13% was in the UK, and we see the other countries that are looking at offshore wind power plant in their electricity portfolio. Now, historically, in terms of total installed capacity, this is maybe the picture the slide that gives the biggest picture. We see that since the beginning of the year 2000, we see constant growth of installation of wind power plants on the planet, with some compounded average growth rate of going nearly in these recent years of about 12%. We see that in 2021, we had 837 gigawatt of total installed capacity. So 837,000 megawatt, 57,000 gigawatt 57,000 megawatt of that capacity was for offshore wind power plants. In 2022, the total number was at about 930, and in this year, 2023, we will see reaching 1 million megawatt of wind installed capacity on the planet. So 1,000 gigawatt of wind capacity, which is huge. Where is Japan in all of that? Well, Japan is at 4.6 gigawatt of installed capacity, and it's mainly onshore wind energy. It's reasonable because actually the land availability in Japan is very low, and the density of population where there's land available is very high. So it's normal that it's difficult to develop wind energy in Japan for onshore wind energy. So that's why the going offshore in Japan is quite interesting, and the future of wind energy in Japan is mainly as offshore power plants. So where will the new offshore wind power plant be installed, or where were they installed in the recent years? Well, we see that now the blue is for Europe, and the green is for China. So you see that China is a big player in the offshore wind energy sector, and Europe has been installing wind power plants for a long period of time. Big increase in China in 2021 was because of policy. Policy were ending in 2021, so industry was pushing to install the power plants before that year. So in terms of the future, well, will the onshore and offshore wind power plant be installed? Well, or essentially the capacity that will be installed, we see that more up to 150 gigawatt of onshore and offshore wind capacity will be installed in the world, and about 36,000 megawatt of that will be for offshore wind power plants. So why is wind energy so interesting? Well, because the levelized cost of electricity is quite low, much lower than the retail price of electricity in various jurisdictions, various countries. Offshore wind power plant, the LCOE is about $34 per megawatt hour, and for offshore wind power plants, it's about $77 per megawatt megawatt hour of energy. Now, what happened once the penetration of wind energy is quite large, so occupying a large percentage of the electricity portfolio? Well, we have some model for that. And again, we see that in Europe, Denmark has roughly 50% of its electricity generated from wind power plant, both a combination of onshore and offshore. We see that Ireland is nearly 40% of its electricity from wind power plants. And we see Germany, UK, at nearly 30% of their electricity coming from wind power plant, both onshore and offshore. So it is possible to integrate a lot of wind energy in an electricity portfolio, and the models that we have are coming from Europe. Same type of information, large installation capacity. Now, going to offshore wind energy. We've seen those nice pictures. We all know these pictures. The benefits of offshore wind power plant is much larger turbine, less transportation issues, low surface roughness, higher capacity factors, etc., etc. And I will say also less social constraint. But in terms of constraints, there's higher project and electricity cost, and there's the seabed and the foundation. So we have fixed foundations or floating turbines. It's also a difficult environment. So access, we need a boat. Onshore, we need a pickup truck to go there. Offshore, we need a boat. It's a salt environment. So corrosive, tidally fixed. There's ice, possibly ice. And there's the fishing industry also that is a potential constraint. Now, the rotor size of wind turbines is increasing. We've seen that. We've seen other people, so I will pass. Now we're in the 10 megawatt range of wind turbines. There's various foundations. This is the graphical representation of those foundations. There's gravity-based, so in order that they appear in the figure, there are gravity-based and suction bucket monopile. It's roughly 5% of the fixed foundation turbines installed. Most of the fixed foundations are monopile, so about 80% of the foundations. Here in Japan, there's offshore wind power plants. There's 271 megawatt of offshore wind power plant. That's not counting the individual prototype demonstration turbines, but strictly the power plants with many turbines. So Japan has 271 megawatt of offshore wind power plant installed, and they are fixed foundations. Now, there's also floating foundations, which for Japan is maybe the future or part of the future for Japan. Various type of floating foundations. So spar submersible at 50% of what's installed currently in the world, spar buoy at 50%, and then there's the other models of tension leg platform and barge type of foundations. Currently on the planet, there are 6 operational floating power plants or in construction, 2 of them being in the UK, 1 in Norway, Portugal, Japan, a small one in Japan, and 1 in France. That is not counting the demonstration floating turbines, and Japan has a few of them here in your country. So we see that the floating wind turbines is not a dominant player, only 188 megawatt of installed capacity. We've seen those pictures of floating turbines. You know this maybe better than I do. Now, what are the country objectives for the offshore wind power plant installed capacity? The leaders, or the ones that are leading, are China and the UK. China wants to install 50 gigawatt of offshore wind power plants before 2025, so that's in 2 years. So 50,000 megawatt. China will achieve this value. With the rate that they are installing right now, they will achieve this value. Germany or UK, 50 gigawatt in 2030. Then we go at the other levels, Germany, US, etc., which also have quite important ambition to install offshore wind power plants. Then we've got the smaller players, and I would include Canada, because the land is so large and so much available land. Offshore wind power plant will not be a dominant player. So where's Japan in all of this? Well, Professor Suzuki, I think, mentioned it. I could see the numbers, did not understand the text in Japanese, but I could see the numbers. Japan has a 10 gigawatt objective for 2030, and a longer term ambition of 30 to 45 gigawatt in 2040. So we see that Japan has large ambition in the short term, but also large ambition for the long term. And Japan is positioning itself, or at least wants to achieve, to be a leader in offshore wind energy on the planet. There's some challenge for that, and I'll conclude my presentation with those challenges. What we see from this graph here is that currently the dominant players of offshore wind energy is China, USA, UK. In the future, it's going to be much more countries that will be part of that development, including here in Japan. There's some wind turbine installation vessels. I will pass this. Now, there's one essential condition when we want to develop wind energy, and that's good wind. So what's the wind here in Japan? Well, this is a global wind atlas published by the World Bank and done by the Technical University of Denmark. And we see here on the scale where it's red and purple is wind speeds, annual average wind speeds reaching 10 meters per second. And this is exceptional wind regime. So we see that Japan is characterized by, at the minimum, excellent, but I could almost say exceptional wind resource in the offshore region all over your country. So wind energy can be a source, an important source of electricity for Japan if you can develop the offshore wind power plants. So it's been quantified that Japan has roughly 400 gigawatt of technical power potential. So much more power available in the offshore wind than the objective that Japan has right now. So confirming that this 45 gigawatt of installed capacity is possible in Japan in terms of the wind resource. We've done some work in Thailand. I will pass this. and I will go to my conclusions. Essentially, what I try to show to you is that we're, in terms of the world scale, we are still highly dependent on fossil fuel, but renewable energy is rapidly developing throughout the world, and offshore wind energy will become an important player in the energy sector across the planet. Here in Japan, same as the world, highly dependent on fossil fuel for electricity generation, but renewable energy for electricity generation is increasing. In terms of the resource for offshore wind energy in Japan, you've got an exceptional wind resource, huge technical power potential, but you have a challenge, bathymetry. Bathymetry, which is the opposite of topography, like topography under the water. But it's challenging. You've got some important near-shore water depth. There's ambitious policy objective, both on the short term, 2030, and on the long term, 2040. But you have advanced and world-class research institutions and university. I spoke about Kyushu University, but there's others here in Japan. And you've got a robust and efficient industrial and manufacturing sector. So when we look at this, it's possible for Japan to achieve its objective. I remind you that I've shown in this presentation that in terms of the current offshore wind energy installed capacity, there's 57,000 megawatt of offshore capacity installed in the world, but only 276 here in Japan, 271 megawatt of fixed floating turbine, a fixed turbine, and 5 megawatt of floating turbine. So big jump to be made. What does this mean? Well, if you want to achieve the short-term objective, which is 2030, you will have to go from 276 megawatt to 10,000 megawatt in 2030. If you divide that over 7 years, that's 1,400 megawatt of capacity that will need to be installed every year. So if you assume that we are installing some 10 megawatt turbines, which is currently available, it means 140 offshore wind turbines per year to be installed over a 7-year period. What this means is that today is Tuesday. If we assume a linear installation over a 7-year period, the first turbine must be installed this Friday, the second turbine next Monday, the third turbine next Thursday, if we want a linear scale of installation. So you see that there's some urgency to start installing some wind turbines. If you look at the long term, if you look at the low end of the long term, which would be 30 gigawatt by the end of 2040, it means that between 2031 and 2040, assuming that we reach the capacity of 10 gigawatt in 2030, it means 2,000 megawatt per year. And assuming this, again, 10 megawatt turbine, this 200 offshore wind turbine per year. Say, well, 200 is not too bad. Well, 200 turbines per year, that means 1 turbine every other day. So if we start on a Monday, we start the first turbine on a Monday, the Wednesday, you need to install the second turbine, the Friday, the third turbine, etc. Over a 10-year period, every 2 days, you install a wind turbine of 10 megawatt and connect it to the grid. If you look at the long-term end, 35,000 megawatt will have to be installed over a 10-year period, and that comes down to 350 offshore wind turbines per year. So essentially, every day you will connect a 10 megawatt turbine offshore, 10 megawatt turbine on the electricity grid. So big ambition, but it's possible. But there's some challenges, and I summarize those challenges is that research and innovation in offshore and floating wind turbine will be critical components for Japan to achieve its offshore wind energy objectives. So the research institutions, research universities must have some support to be able to develop this capacity, to feed this knowledge and to create new knowledge and feed this knowledge and do innovation to achieve those ambitious objectives for Japan. It's well known that when you develop a new industrial sector, a new manufacturing sector, you need what we call in Canada HQPs, highly qualified people. So there's an urgent need to train massively HQP in wind energy here in Japan, both for onshore, but mainly for offshore wind energy application. You need to develop a specialized manufacturing and installation capacity for offshore and floating wind turbines to be able to meet those objectives, the long-term, short-term, and long-term objective of the country. And finally, we're technical people. I think most of us in this room here, so we tend to focus on the technical aspect, but we're not the only users of the sea. There's other industry, other users of the waters and the sea. So essentially, there will need to be a continuous work to minimize the conflicts with other users of the seas and to ensure the social acceptance of offshore wind energy projects here in Japan. So in conclusion, Japan has the wind resource, has the research and training institutions and universities, has a strong and robust manufacturing capacity, but we need to start the soonest possible to be able, if you want to achieve the goals that are set for 2030 and 2040. Sorry, I took maybe a little bit more time, Mr. Chairman, but this is what I wanted to talk to you about, and hopefully in 10 years or 20 years from now, there will be much more light on this planet than what we see here today. Thank you very much.